Let's look at the solution of algebra bytes. Okay. What is the least value of the expression a plus b into b plus c into c plus d into d plus c into e plus a divided by a, b, c, d, e if a, b, c, d, e are positive real numbers? The simplest way or the trigger that should work here is, given that if you replaced a with b and b with a, the expression would remain the same. The best way to proceed here would be turn everything into the same variable, take everything to be equal. Effectively, you would end up getting 2a raised to the power 5 in the numerator and a raised to the power 5 in the denominator, 32a raised to the power 5 in the numerator and a raised to the 5 in the denominator. Cancel, cancel. You get option D, 32. Next, if fx is equal to min, this quadratic expression and this linear expression, then find the maximum value of fx for x being a positive real number. Okay, let's see. We would have it as how do I put it? Okay, if you look at this expression, it would be something like this, quadratic and a line going through it somewhere, line cutting it at 2 points. So I'm saying it is something like this. So the 2 points that we have, and the portion that will be useful, because this is a min function, the portion that will be useful is this one here. But we have also been told x is a positive real number. So we also have to ensure that x is positive. The best way to proceed is, of course, to equate them. So we get 18x square minus 9 is equal to minus 9x. Bring it over to the other side. 18x square plus 9x minus 9 is equal to 0. 2x square plus x minus 1 is equal to 0. 2x square plus 2x minus x minus 1 is equal to 0. 2x x plus 1 minus 1 x plus 1 is equal to 0. And therefore, 2x minus 1 x plus 1 is equal to 0. So the intersection points are such that x would be there equal to half, or x would be equal to minus 1. So this point here is x equal to minus 1, but I can't use it. And this point here would be where x is equal to half. X is equal to half. And the cutoff point is, of course, let's say x equal to 0. So the key points that you have to look at is this one and is this one, these 2 points. So let's put x equal to 0 because we wanted positive real number. X, if x was equal to 0, fx would turn out to be min of minus 9 comma 0, or it would be equal to minus 9. For x equal to half, it would be how much? 18x squared. So 18 by 4, 4.5 minus 9 comma minus 4.5 or equal to minus 4.5 itself. Between the two of them, of course, this is greater. So answer has to be option B. Next, find the area of the region bounded by the graphs x minus y is equal to 4. Mod x is equal to 4, mod y is equal to 4, containing the origin. Okay. Make a graph for this. X equal to 4 would be given by these lines. Y equal to 4 or mod y equal to 4 will be given by these lines. Here we would have y equal to 4, y equal to minus 4, x equal to 4, and x equal to minus 4. These 2 lines are easy to make. This may not necessarily be easy for all, but can we see x minus y is equal to 4? Can I say if I took x as 4 and y as 0, my life would be simple. So one point is of course this one here. Another one would be 5 and 1, then 6 and 2, so on and so forth. Can you see the line will go something like this? And it will keep going this way. But these are not the only values. We will also have the same values if we were working with -4, 0, -4, 0, then -5, -1, then -6, -2. Basically, this would be the starting point, and the line will keep going this way. It will, of course, cut it off at this point where x is 0 and y is 4. So now look at the area for which we need, the region for which we need the area is this one here. The region for which we need the area is this one here, because we want the area containing the origin. This is the portion. So this entire length is 8, x equal to -4 to x equal to 4. This entire region is also 8. So total area for the large square created is 8 into 8. From this, we have to remove this triangle. This length here is 4. This length here is 4. And the area in this triangle and this triangle is the same. So -2 into half into 4 into 4. Cancel, cancel. 8 into 8 -4 into 4. 64 minus 16. Final answer to the question will be 48. Next, find the area in square units of the region bounded by mod x plus mod y is less than equal to 6 and x plus 2, x plus y whole mod is greater than 2. Okay, again, let's create a graph. So let's say x was 0, y can be a maximum of 6. So x 0, y 6, I would have this point. Another point I can see is this one here, 0 and -6. If x was 1, y can be a maximum of 5 or -5. So it can be 5 or -5. Can you see? We are getting a line something like this. Also, just because we have gone there, we can also go -1 and 5, -1 and -5. So you'll also get a line like this. The cutoff points are easy enough to determine. This will be 0, 6, 0, -6, 6, 0, -6, 0. So this has been drawn. This has been drawn, no problem at all. Next, we are left with x plus y whole mod is greater than 2. So let's say x was 0. Minimum value that y can take is 2. So if x was 0, minimum value that y can take is 2. Would be at this point 0, 2. And not just 0, 2, it would also be at 0, -2. 0, -2. In fact, if we have 0, 2 and 0, -2, can I say if I got x equal to 1, if I got x equal to 1, y would also need to be 1. Maximum value that y can take is 1. Or y can also go to -3, 1, 1 and 1, -3. So you would get some line like this, and we would get some line like this. Of course, this keeps going this way, this keeps going this way. Where would it cut it off? Hopefully you can see the region where it will cut it off will be 2, 0. And the region where it will cut it off will be -2, 0. Now see, because it was less than 6, this region here is being referred to, and because it is greater than 2, again region outside of this is being referred to. So we need this area plus this area. We need this area plus this area. We simply need to remove this cross area from consideration. Remove this cross area from consideration. Okay. Let us identify the intersection points here. 2, -2 and 6. So this will be -4. 0, 0, increasing at the rate of 1. So it has to be -4, -2. Here it will be -2, -4. Here it will be 4, -2. And here it will be 2, -4. What just happened? Okay. These are the 4 points. For the larger rhombus in play, can we say the area will be half into the diagonals are 12 into 12 or equal to 72. This much is easy enough to find out. Let's say for A, B, C, D, half into 12 into 12, 72 is easy enough to find out. Now for this shape, I need area of this quadrilateral -4 to -2, 4. And here -2, 4 to 4, 2. Okay, let's see. This here, hopefully you can see, is turning out to be a perfect rectangle. Perfect rectangle. So I need the length of these places. No, I just change the color so that it is easier to understand. I need this length and I need this length. Between these 2 points, what will be the length? -4 minus -2. So 2 ka gap. This is 2 ka gap. This is 2 ka gap. 2, 2. So this will be 2√2. And here, what do I have? The x-axis is changing by 6. The y-axis is also changing by 6. So 6 and 6. So this here will be 6√2. So from this, I have to subtract 2√2 into 6√2. Or I have to subtract 24. 72 minus 24. My final answer will be 48. Drawing diagrams is extremely important. Or knowing how to draw diagrams is extremely important, not in a formula. Next, if P is greater than -10, Q is less than 8, and R is greater than 10, then which of the following is true? Okay. This seems like a fun question. If P is greater than -10, so let me take P as 1500. Q is less than 8, so let me take Q as -1500. And R is greater than 12. So let me take R as 1500. Can you see 1500 plus 1500 plus 1500? I'm getting 4500 here. I'm getting 4500 here. So this is definitely not the answer. In fact, at this time itself, can I also rule out C? This is also gone, not correct. A is not correct, C is not correct. Let me go ahead and check P, B and D. Okay, P. Because this is greater than 10, now my strategy would be to take minimum possible value. Let me take P as -9. Q is less than 8. So let me take Q as -1500. And R is greater than 12. So let me take R as 30. So -9 plus -1500 plus 13 is greater than 10. Of course not. This is also ruled out. Now A, C, B are ruled out. Answer has to be D. If we were checking for the options, then ideally it would be P minus Q plus R. So I'm looking at P and R. Can I say P plus R has to be greater than 2? P plus R has to be greater than 2. Simply because P is greater than -10, R is greater than 12. P plus R has to be greater than 2. Now, if I introduce this same term here, if I introduce the same term, but on the opposite side, plus q here plus 8 here. Then I take q to the other side. P minus q plus r is greater than minus 6. Yo, I'm getting the last expression. I can reach the answer directly also, but it is much more fun to assign values yourself, play God in the storyline, and then get to the final answer. That will be all for this algebra bytes. Hopefully you learned something. That will be all. Okay, bye.